Hello children, let us study the topic leaf. You all know that leaf is the flat extended part of the plant and it is responsible for the photosynthesis as it is green in color. Now let us see the various parts of the leaf. First thing, this whole part is the lamina. This flat expanded portion is called as lamina. Inside the lamina you can see a straight line that is called as the midrib. In all the leaves you will see a straight line that is the midrib. This midrib continuation you will find a stalk and this stalk is called as petiole. Most of the plants have the petioles. If they have the petiole, they are called as petiolate flowers. Here you can see there is a stem. On the stem at some points you will see the leaves are coming out. The point at which the leaves come, that point is called as node. From the node the stalk is coming. This stalk is called as petiole. But some flowers or some plants, they do not have this stalk. They don't have petiole. If they don't have petiole, it looks in this way. That is, on the stem directly the leaf is present. Such leaf is called as sessile leaf. And if the petiole is present, it is petiolate leaf, and if the petiole is absent, directly the leaf is present, it is called as the sessile leaf. So this about the petiole. We have seen the flat extended part, green part, that is called as lamina, and this lamina has the continuation of the petiole that is called as the midrib. From this midrib you can see again some branches arise. So these branches are called as veins and veinlets. From the back side also you can see this is the midrib. These are the veins, and again if you clearly see, again you will find the network here, and that is the veinlet. The veins and veinlet just form the network for the supply of water through each part of the leaf. So this about the lamina and the stalk. At the end of the leaf you will find leaf apex. Each leaf has the upper end that is called as a, so this part is the leaf apex. Here you will find this is the leaf apex. So the end that is called as the leaf apex. Now here this part, outer margin, this is the outer margin. You can see that each leaf has the different type of margin. There are different margins to different types of leaves. So here we have seen the structure of the leaf. It is just the flat expanded part called as lamina, green in color, responsible for photosynthesis. At the base you will find that is the stalk. Some have the stalk that is called as petiole, and that is called as petiolate leaf. Does not has the stalk, then it is called as sessile. In the lamina you have seen there is a midrib, and the veins and veinlets, they form the network. And we have also seen the uppermost last end that is called as the leaf apex. The end of the stalk where this leaf is attached to the plant, that is called as leaf base. The end of the stalk where the leaf is attached to the plant, this point is called as the leaf base. Now next point we have to study, that is venation. Now on this lamina we have seen there are veins and veinlets. The arrangement of the veins and veinlets is called as venation. There are two types of venation. In this leaf you can see there are the veins, and on these veins again you will find the veinlets. And these veins and veinlets, they form a network. This is called as reticulate venation. But in this leaf you will find some different structure. Here you can see this is the midrib, and some lines are running parallel to the midrib. They never intersect. The lines, if they are running parallel to the midrib, they are called as parallel venation. This also, it is another type of leaf. Here you will find straight lines. This is the midrib, and besides the midrib you will find some straight lines running, and this is the parallel venation. This parallel venation is generally found in the monocots, and the reticulate venation is found in dicots. So these two types of venations we have seen forms the network. the lines go parallel. Now, the next type we are going to see, that is the simple and the compound leaf. Here you can see that this is the stem, and on this stem from one node one leaf arise. If from one node one leaf is arise, that is the simple leaf, and this lamina is not divided, it is whole one single leaf. But sometimes that one leaf, it is divided into small leaflets. Such type is called as the compound leaf. Again I repeat, for the simple leaf there is a single entire undivided lamina. This is the simple leaf. And if you talk about compound, then here you can see that the single lamina or single leaf is divided into small leaflets. So this is the example of the compound leaf. And if you talk about this is a simple leaf, because from one node one leaf is there, this is a simple, and from one node you will find the leaf is again, lamina is again divided into small leaflets. So this is a compound leaf. Now the next point is phyllotaxy. Phyllotaxy is the arrangement of leaves on the stem so that each leaf can get sufficient amount of sunlight. So there are three types of phyllotaxy. Let us study the first one. The first one is alternate. Here you can see that on this stem, at each node you will find one leaf. At each node you will find one leaf. But see the arrangement. From one node there is one leaf coming below. To the next side the leaf is there. Again you come below to the opposite side. Again when you come down, the leaf is on this side. When you come down, the leaf is on this side. So this is called as alternate phyllotaxy. This again is the example of alternate phyllotaxy. Here you can see from one node single leaf arise, and one leaf goes to the right side. Below it goes to the left side. Again to the right side, again to the left side. So this is the alternate phyllotaxy. Next is the opposite phyllotaxy. In the opposite phyllotaxy you can see from each node two leaves arise and they go side by side. From each node you can see two leaves are there. They again go side by side. So this is the alternate phyllotaxy. Again one example for alternate phyllotaxy. This is the alternate phyllotaxy. From one node one leaf to the right. From one node one leaf to the left. Again to the right. Again to the left. And in the opposite you have seen side by side. From one node, from one single node, two leaves arise and they go side by side. And the last one, that is the whorled phyllotaxy. In the whorled phyllotaxy, you can see that from a single node, many leaves arise and they form the whorl. Again, below that, to the another node, you will find again there is a whorl. So in this way, there are three types of phyllotaxy, and the purpose of phyllotaxy is that each leaf can get sufficient amount of sunlight.
If you like my video, so please like and subscribe my channel for getting the new exciting videos. Thank you.